Hi guys, welcome back to another video in this series of learning Kotlin. In the last video we saw how to define functions and how to pass arguments to functions. In this video we'll learn more about functions, about named arguments, default arguments, function overloading, and also some vararg arguments to functions. So we have a set of tasks that we need to complete, and in the process we'll learn more about function arguments. So let's look at the first task. Define a function called wrap that wraps a string with a prefix and suffix of type character. Okay, so we need to wrap a string with a prefix and a suffix. Let's define a function called wrap, and let's pass it the string to be wrapped. Let's call it str of type string. Let's pass the second parameter prefix of type char and this third parameter suffix of type char, and let's return the wrapped string. So we can have something like prefix plus str plus suffix to return the string. Let's invoke this function from main with some argument like Kotlin and wrapping it in open and close square brackets. So when we run this code we should see the wrapped string, and so far so good. Okay, let's look at the second task, which is write a unit test for this function. So Command Shift T on main, create a new unit test file, tests plural again, just because we might have more than one test. src test Kotlin, remove the internal classifier, for now we don't need it. Create a test function, give it a good name like given. Here we can look at the backticks option in Kotlin, which allows you to have names with spaces in them. This is particularly useful in names of the unit test functions, as we can have more sort of like English sentences for the names. So I'm going to use the backtick notation from now on, and I'll name my unit tests with the given, when, then format. So given a string when wrapped, then should be wrapped with prefix and suffix. Cool. Let's take a string str equal to Kotlin, and this is our expected value. Wrap str in square brackets. Oops, this is the actual value. Expected should be Kotlin, actual is this, assert equals expected to actual, and when we run this test it should succeed. Okay, so let's get back to our tasks. We completed the second task of writing the unit test. Let's look at the third one. Let's say the prefix and suffix are optional and default to the square brackets. Okay, so what we want to do here is we might have a function with some behavior, but we want to always allow the call site. This is the call site. The call site is where you are actually invoking the function. So we want to give some convenience to the call site by providing default values for certain arguments so that the call site can be a bit concise. So let's say if it were to look something like this, wrap Kotlin, and it by default it just wraps to the square braces. So how can we do that? In Kotlin we have default arguments, so we can actually have the default value for an argument specified in the function definition, and by doing so you see that in the call site we only need to specify the string now, and the prefix and the suffix values are considered to be the default values, which are the open and close square braces. When you run this code, it should perform it should print the same value as output. Let's also go to our test and run the test with and without the default values. So let's copy this, paste, say when a string is given a string with no prefix and suffix supplied, when wrapped should be wrapped with default prefix and suffix. I hope you can read this. So here the backtick notation really helps, so you can actually just write something like a sentence for the test name, which is very descriptive. And let's modify the test by removing the prefix and suffix. You should get the same output and both tests should compile. Oops, I only ran one test. Okay, I'll run both now. Okay, so that is the default arguments in Kotlin. At the call side, let's say if you have to specify something, let's say you only have to specify the suffix and you want the prefix to be the open square brackets. So if you do this, because it's the second argument, it will be taken as the prefix. But let's say if you only had to specify the suffix, you can actually qualify the argument with the name of the parameter. This is called as a named argument, and by doing that the compiler understands that this is a third argument, that is suffix, and not the prefix. When you run this code, you should get the proper suffix specified. These are named arguments, and yeah, that explains what named arguments are on a high level. The fourth task is, let's say we need strings as prefixes and suffixes too. So right now we were only dealing with char types, which are characters, but let's say we want to give the convenience of having something like xyz as suffix, which is a string. So to do that, what we can do is we can overload the wrap function and make it handle strings. So instead of giving a character, now I can default to a string. And the rest of the function behaves the same. Just going to format. So now we have an overloaded version of wrap, which one of them takes chars as prefixes and suffixes, and the other takes as strings. So with these two functions, your call site will look like this: wrap Kotlin with curly braces as prefixes and suffix. So you get the expected behavior. The thing to note here is when we are overloading, so this in Java would actually act as an overload on its own, with like one argument and one with prefix as a default value, suffix as a default value, and one with prefix and suffix both as default value. So there will be like 4 overloads in Java. In Kotlin, all those 4 overloads are handled in a single definition, which makes it more concise. You also have named arguments to help you specify what exactly you want to mean by this value, like is it the prefix or the suffix. This is an actual overload, Java style, wherein one argument of the one parameter, one overload of the function takes an argument, and the other overload takes a string argument. So with this combination of overloads and default and named arguments, your call site becomes pretty concise, and you get a lot of behavior. And overloading really is, becomes more meaningful and helpful in the context of your app. The call side need not worry about what different values can be specified, but it is more intuitive for the user. Okay, so we handled task 4. Let's look at task 5. Define a function that can take 3 arguments and return their sum. Okay, so we already know how to define functions. I'll quickly write a function that can take 3 arguments and return their sum. The return type is here, which I already know will be an int, and I'm just going to return the sum of 3 ints. It's an easy one. Write a unit test for this function. Okay, so we already have a unit test file. Let's go there and let's wrap. Okay, what is going on? Oh, okay. Yeah, we need to specify the default arguments, because if you don't specify the default arguments, the compiler does not know which version of wrap it needs to call to. Is it this one or this one? Even though you've specified default values for these second and third parameters, but still, let's say if you had something like this in one of those functions, the compiler would not know which one to call, and you would expect the one with the hello string to be called, but the compiler does not read the code inside the function. It just reads the signature in order to understand which one it needs to call. That's why you need to specify the right arguments. I think they should be this, so that the test passes. Okay, now we need to write a unit test for our sum function. Given 3 ints, when sum, then should return their sum. Okay, well expected, let's say 40, while actual is sum 10, 20, 10, and assert equals should be expected actual. When you run the test, they should work. For some reason it's not running all the tests. Okay, now it runs, and yeah, that's working. Let's get back to our code and let's look at the final tasks for today. Define a function to take any number of arguments and return their sum. Okay, so this one takes like 3 arguments, but what if we had a requirement to, I'm just going to call it here. What if we had a function that could sum any number of arguments? So to do that, we can use the vararg keyword, and we can say nums as the name of our argument. This is similar to varargs in Java, and when we return, there's a built-in sum function on ints that we can use. When we return their sum, it should return the sum of all the arguments that you pass. Now varargs can work on 0 up to any number of arguments. So when you sum 0 number of arguments, it should return 0. But if you sum, like, let's say 4 values, it should return their sum. in this case 14. Yep. So that's how vararg works. However, if you look at this this IDE hint that you're getting over here, it says that these arguments are of type nums with the triple dot, meaning that they're varargs. But if you were to specify 3 of them, then the version of sum that can take 3 arguments is called. So varargs are like the least preference. If you have something more specific, that will be invoked, and if you don't have anything specific, then the varargs overloaded version of a function will be invoked. Okay, so that's it for this video. Do check out the resources that I have in the description, and also the GitHub repository where you can get to work on these tasks. Do leave your comments if you have any on this video, and I will see you in the next one. Thanks. Have a good day.